Great, so welcome back, and this is question number 226, and here we're inverting a binary tree. So for this question, we're given a root of the binary tree, and we just want to return the root at the end. So we can just put return root here, since we're just passing the parameter. And so, yeah, inverting a tree just means that we're going down the tree and we're swapping their nodes. So the root always stays the same. And here you can see that 2 and 7, they swap places. And then these leave nodes, not only do they mirror to the other side, but they also swap places. So 1 and 3 are moved along with 2 onto the right side, but then the values themselves also swap. And then a simpler case here, 2 stays the same because it's the root, and then its leaves swap values. Okay, so to do this, we're going to be using a queue, and this will be just to maintain an order as we're going down this list, so that we're doing it in a breadth first search way, where we're going from the current node left and right. And so we'll just be adding the nodes onto our queue as we're going down this list in breadth first search. So why don't we go ahead and declare a queue, and it'll be of type tree node. We're given that class here. Okay, and then next we're going to actually add to our queue this root value first, since it'll be the first node that we're looking at in our tree. And it's offer. So let's pass that root node. Great, and so now we're just going to enter while loop and just while the queue isn't empty. So we're just going to continue to iterate, and then once we've gone through all of the nodes in our tree, then we'll just return the root. Okay, and so now what we want to do is just grab the node in our queue, since it's first in, first out, so like the first out of our queue. So we're popping it off our queue. So tree node, we'll just call it node equals queue.pull. This just grabs whoever's first in line, and then we'll also want a temporary variable, and we'll just call it left, and it will be equal to node.left. And that's just because we'll want to grab the left and right nodes from our current node, and in the base case it's the root node. So to do that, what we'll do is let's think node dot right is equal to node dot left, or no, node left is equal to right. Yeah, there we go. And then we want to set the right one equal to the left one, so node dot right is equal to left. And that's why we're using this temp variable here. And so next, we'll just want to set, if our node left and node right aren't null, we'll want to add them to our queue to look at next. So first we'll do the left one, since we're going left and right. So if our left node isn't null, we'll want to just add that to our queue. And same thing for our right node. We want to add that to our queue as well. Great. So let's go ahead and try that. Oh, we're just returning our root at the end like they specified with, and at the end of that while loop, after we've swapped and inverted all of the nodes, it'll be good. And so we just point to the back to our root. Let's go ahead and run that. Oh, I said off. I must have deleted that by accident last time around. Accepted, and try submitting it. Oh, here, no dot left. Let's see. So I think we'll have to just check whether or not our root is null. So if root equals null, we'll just add that in parentheses. We'll just want to return -1. That's just the base case. Let's try that. We'll just return null. There. And submit. Great, and success. So sorry about that. So what that was is that it was erroring out here on the left, saying that, well, node here was null. And so because this handles checking that these are null, I knew that, okay, every iteration after the first one can never be null, so this node value would never be null. And then I was like, okay, so the only other case that this could happen would be the base case if we're given a root that is null. And that's just something I forgot that you should always consider is, okay, if the value from your parameter is just null or empty, just return null or -1. So, and although this is a tree node type, we can still return null. I tried returning -1, which didn't make sense. So yeah, so I hope that helped, and good luck with the rest of your algorithms. Thank you.